Hey everyone, welcome back to Doodle Homework with your girl, half a cup of sugar and a stick of butter, Doodle Kara. Today, we're walking through how to do hybridizations. In this video, we're going to look at understanding orbitals, how to do electron configurations, the difference between Sp3, Sp2, and Sp hybridizations, and finally, how to visually represent all of this in a drawing. Of course, the first thing that we need to understand are the shapes of the orbitals. The s orbital is sphere shape and can hold up to 2 electrons. The p orbital is hourglass shape and can hold up to 6 electrons. These are the 2 orbitals you will use for most every orbital hybridization you'll do. But just for funsies, let's go ahead and look at the other 2 types of orbitals we have. D orbitals look like overlapping p orbitals and hold up to 10 electrons. And lastly, f orbitals look like a lovely flower and can hold up to 14 electrons. Now that we have the basic shapes out of the way, let's go ahead and look at a hybridized orbital shape. This orbital is literally the addition of an s and p orbital together. Like adding 1 plus 1, we get the result with one side of the orbital being longer, like in a p orbital, and one side being shorter, like in an s orbital. Overall, when we're drawing these into our molecule, we ignore the small side and only draw in the longer part. This makes sense when you think about it, because bonding electrons always want to be the farthest distance away from the nucleus as possible. Moving on, we have a few steps that may help organize the procedure when it comes to drawing out these orbital hybridizations. And I know, but the first thing I always tell my students to do is to draw out the Lewis structure. So that is going to be step 1 to all of this. This makes it very easy to identify single, double, and triple bonds. If you need help on how to draw Lewis structures, check out my other video that goes through step-by-step how to make them. The next step is optional, but it does provide another checkpoint to make sure that you understand which orbitals you're working with, and that is to draw out the electron configuration for the atom you're trying to decide the hybridization of. Like I said, it is optional, but it's great to do a little check mark on all of the s and then p orbitals that you have for that atom. The third step is to draw your hybridized orbitals around your central atom, including those electrons. Finally, once you've drawn in your hybridized part, you can go ahead and draw in your unhybridized parts, along with any atoms or extra electrons attached to that central atom. So this would include, for example, your hydrogens. All right, so let's put to work everything we just talked about in an example of methane. Methane is CH4. This means when we are drawing the Lewis dot diagram, we will show that electrons are being shared by all 4 hydrogens and the central atom of carbon. This helps visualize that this is all single bonds attached to the carbon. Looking at carbon's electron configuration, we can fill out the orbitals 1s, 2s, and 2p mostly. What ends up happening here is that the extra electron held in the 2s subshell moves to be part of the 2p orbital. This lowers the energy of the 2p orbital, hybridizing both the 2s and 2p. Now we can rewrite this as 4 boxes that are all just sp3 orbitals. Where did this sp3 come from? Well, since we have all 4 bonds attached to the carbon, all 4 of our orbitals are going to be hybridized. This means that if we check this out, count it up 1 through 4, we see that the S and all 3 have at least 1 electron in them. That is how you get to your sp3 hybridization. Drawing our hybridized orbitals around that central atom of carbon, we're going to use what we previously saw as the shape for the sp hybridized. So we're going to have long ends going out of our carbon and 1 electron within each of those orbitals. Then we write in our hydrogens and also attach the electron from the hydrogen to those orbitals, overlapping with the sp3. This finishes and completes our hybridization drawing for methane. Before moving on to the next example, there are some rules that you'll want to memorize. While we can look at the Lewis diagram and we can look at the electron configuration, knowing if it's a single, double, or triple bond holding atoms together will actually tell you if it's sp3, sp2, or sp hybridized. All single bonds will result in sp3. All double bonds will result in sp2. And all triple bonds will result in sp hybridization. Note, though, this is for one atom. So if we have a molecule that has a bunch of different bonds held together, each central atom may have a different hybridization. Let's take a look at this next example and you'll see what I mean. The next molecule we're looking at is but1ene or 1-butene, depending on how you want to say it. This is C4H8. Drawing out its Lewis dot diagram, we would see that 2 of the carbons hold 4 electrons between each other, noting that this is a double bond. All the rest of our carbons only hold 2 electrons between each other, noting that this is a single bond. Your teacher may draw out the expanded form or the stick form, or they also may tell you if there are sigma or pi bonds. Note that all single bonds are sigma, all double bonds have 1 sigma and 1 pi bond, and all triple bonds have 1 sigma and 2 pi bonds. So that is also a good rule to know for these drawings. As you can see, because our different carbons are bonded either using a double bond or single bond, they're going to have a different hybridization. For example, the carbons with the double bonds will be sp2 hybridized, and the rest of the carbons with the single bonds will be sp3 hybridized. So when we are drawing out the hybridization drawing for this molecule, we will go ahead and add in those characteristics. So the first 2 carbons will have an unhybridized orbital. Note that our unhybridized orbital will be a p orbital, and if we go back to the beginning and look at that shape, it is a full hourglass. So instead of writing or drawing the hybridized orbital, the sp hybridized, we will actually draw out the full p orbital. This will occur for those first 2 carbons, and then the rest of the carbons will show that they are sp3 hybridized. So you can see that there are no unhybridized orbitals for those 2 carbons. And then lastly, you go in and you attach the rest of your hydrogens to those sp2 or sp3 hybridized orbitals. And there you have it, the various ways that we can draw out orbital hybridizations for compounds. If you enjoyed this video, don't forget to like, comment, and subscribe, and follow for more obvious science videos like this one. So there you go. Have a good one, and bye!